Tonight is Tuesday, May 14th. This is Managerial Economics, our first meeting for the summer term, 2013. My name is Roger Strickland, and I'm saying all this so I'll have it on video when I remember to edit it and post it to YouTube. I will post our classes, or at least the bulk of them, the pertinent parts, so if you can't make it to class, you'll at least have a sense of what all we were doing. How do you like Canvas? Anybody finding that workable? Anybody having some problems? I'm having a nightmare with it. But eventually things will work themselves out. There is no textbook for this course. The textbook we were using, I found 10% of it useful. I taught this course last term, and the students told me, said, I never wrote my textbook. I said, okay, then we'll stop buying the damn thing. And what that does mean is while you may be saving $50 or $100, you're going to pay real close attention to the notes and the materials that I provide to you, because that's all there is. If you get it all confused anytime along the way, you got to let me know. Feel free to interrupt me here in class. If you're working on some of the homework at home and it's not clear, post it to the discussion forum so everybody can see what your issue is and how we resolve it, and everybody can learn from that. If you run into an issue that is more personal, email me on Canvas. We'll resolve that. I'm asking you also, I think most people have done it, send me an email on Canvas to let me know you're in the course. That's how I'll record your attendance. So, where do we start? There's a midterm and a final. That's your whole grade. You have to make a C on the midterm to continue in the course. The attrition rate last term, I started with 39 students. I finished with 11. Of the 11 who finished, 7 of them came to class regularly. This is a difficult course. It's got enough math and enough conceptual material in it that being in class and asking questions tends to help. I'm preaching to the choir here in this classroom, but I'm intending this to those of you watching this on video as well. It takes a lot of discipline, a lot of focus to get hip deep into this stuff right now. We're going to start working through some questions tonight, some of the problems. And you've got to wade into it. This is a quantitative course to some degree. That means you need a calculator, and in fact you'll need a let me be sure I'm not misleading you here. Yes, you'll need a financial calculator for the second exam. This is a calculator that has the time value of money calculations on it, or functions. I recommend the Texas Instruments Business Analyst 2. It's about $30 at Walmart, or I've got an app for it on my iPhone. It cost me $15. You'll need it in the finance class as well, at least if I'm teaching. There is no alternative but to really spend a lot of hours working through these problems. I encourage you to correspond with one another on Angel and work in study groups and stuff like that. And let me know when you have some issues. For me, this course is not managerial economics. It is managerial economics, and the emphasis is on the management side. How do you take economic theory, and put it to practical use? And that's where my focus is. So a lot of what I'm trying to drive you at is, if you're in the real world, if you're in a business, if you're facing this kind of a demand, these kind of customers, what do? And how does economic theory inform your decision making? So, accordingly, there are some very basic videos I've asked you to look at or review that really come from microeconomics. If you took microeconomics within the last year or two, hopefully that'll come back to you reasonably quick. And if you haven't seen micro in some time, you may want to spend a little time getting comfortable with it. But those are for review. Where I'm beginning tonight is that you've had micro, you understand what a demand curve is, And now we're just going to kind of take it apart. And we're going to look at what happens when you put demand and supply together and create a market, except we're going to do it mathematically rather than just with graphs. Because a lot of the data we use in the real world is expressed mathematically. For example, in micro we say, well, here's the demand curve for a product. Well, where'd it come from? How do you know that when the price is $19, the company sells 115 units per day? And on those occasions when they dropped the price to $15, they saw that their sales increased to 147 units a day. How do you know that? Where did you get that information? And how do you know that for every point along the demand curve? Because that's what our consumers are doing. That's what our customers are doing. Well, how do we find that information out? Research, market research. Sometimes our company does it. Sometimes we hire an outside company to come in and try and give us the data to construct this demand curve, which tells us how our customers are behaving. Now, this may be kind of practical to think of if you're saying, well, if I'm in a small business, you know, I'm making baby carriages. Yeah, I want to know what's going on in the market. But what if you're working for a hospital, a large institution, a government agency? Does this have any relevance? And the answer is yes. People do things based on what it costs them. And that's what a demand curve is telling you. You may have 115 patients a day in the doctor's office when his office visit is $49. But when he drops it to $45, maybe you have more patients. It's the same idea. So the first thing we're going to do in the course, a little bit of math, and just kind of illustrate some of these points. The first calculation I want to do tonight is historical in perspective. Hopefully you saw this in micro, but if you didn't, see if you can stay with me. It's not very difficult, really. When we express a demand equation, we do it usually mathematically, and it's something like this. The quantity demanded, the amount people are going to buy, is equal to some number, we'll make it up, 1,120, minus 4 times the price. So there's a demand equation. If your market research people came to you for your company or your institution and said, here's your demand curve, well, what does that mean? What do those numbers mean? Start at it this way. If the price was 0, how many units would people take? 1,120. Okay? If the price was $1, how many would they buy?
1116.
How did you get 1116?
You plug in 1.
Plug in 1 for P and subtract. I mean, it's not rocket science, is it? And if the price were 2, how many would they buy?
18.
11,
I mean 12.
11, 12. That every time the price goes up $1, they buy 4 units less. That's what that equation is telling you. And so the -4 here is the slope of this demand curve. It's the speed at which the demand curve falls. And if that slope were 14 instead, what would that tell you? How would that compare to the first one?
Steeper.
A lot steeper, and that people are a lot more sensitive to price. Or a nice drop in price may you bring in not so much, maybe a lot. So we look at the equation. And we do this, in this course, we don't get that complicated with the math. This is a straight line function. When you graph this, it's a straight line. How would you graph that, just for grins? Basically, you know it's going to be a straight line because it's got a constant slope of -4. And how do you define a straight line? Remember that from old plane geometry? 2 points defines a straight line. Find any 2 points up there, you got the curve. So let's find this point up here and this point down here. Remember, this is quantity, this is price. What do we know? Let's call it point A. What do we know is going on at point A?
It's 0.
What's 0?
It's -4.
Huh?
-4.
No. What has gone to 0 up here?
Quantity.
Quantity. So if quantity is 0, if 0 is 1120 minus 4p, solve for p.
That's 11/16
Oh, huh?
for P. Oh, P is 0, sorry.
Yeah, p is, no, q is 0. At this point right here, q has gone all the way down to here. Remember, this point is this point represents that and so forth. This would be the point where p has gone to 0. If you solve this, you get 1120 equals 4p, and therefore p is whatever. 88?
8:30.
830?
Is that right?
No.
280.
I got 280.
Yeah, 280.
Yeah, I'm sorry, no, 280, good. So we know that this price value is $280. So at this point here, price is 280, quantity is 0. That's that point. Is that making sense? You remembering some of this? Then how do we solve for this point down here? Go back to the demand equation and plug in 0 for P, because price has gone to 0. So now we've got QD is 1120 minus 4P, and P is 0, so QD is equal to 1120. So we know this intercept down here is 1120. And now that we have 2 points, and we know it's a straight line curve because the slope is constant, hey, that's our demand curve. So that's how we're kind of using math, that it's not very complicated math. You okay with that? And remember then, the coefficient in front of price here, the -4, that's the slope of the line. We'll be using that a lot as we go along. So, suppose we know that the demand curve is 1120 minus 4P. And remember, the way we always did it in microeconomics, we had a supply curve and a demand curve. So if we said, well, the equation for the supply curve, and I'm making this up, let's say it's minus 16 plus 7P. Could you graph that for me? Could you graph the supply curve from this equation? Plug in 0 here, plug in 0 here, and get the 2 intercepts, or approximately. So, leaving that aside, let's just take it as, okay, we have these 2 equations. How do we solve them for the equilibrium point, the point where the demand curve and the supply curve intersect? Set them equal to each other. So we would say 1120 minus 4P is negative 16 plus 7P. And what do we have now? One equation with one unknown. Tell me what the value of P is there. Probably, I'm just slow.
Odds wrong. Sorry.
So 103.27.
Yep. $103.27. You okay with that? How would you solve? This is the equilibrium price now. Star, P star is equilibrium. How would you solve for the equilibrium quantity? Good. Take the 103.27 and plug it back in up here. And just to check it, plug it in up here. And you should get approximately the same number. There's a little rounding, decimal rounding up here. Plug it in. You get 1120 minus 4 times, let's just call it $103 to make it easy. That's high math, right? That's what I hate about this calculator. It doesn't always take your input. Anybody?
708.
Sure sounds good to me. That's an estimate for Q. What do you get up here when you plug in 103? $721 minus 16 is 705. So those numbers are pretty close together, right? 705, 708, so that's about right.
And what did you say they were called out again? The equilibrium?
This is the equilibrium price and the equilibrium quantity. If we were looking at this on the graph, demand, supply, this would be the price, $103 and change, and this would be the quantity, oh, I don't know, call it 706 just to we round it off a little bit. You okay with that? When you pick up problem set number 1 and you go to question number 3, this is kind of what they're asking you to do. And that is meant more as a refresher than hopefully anything brand new. Now the way this can get a little more complicated, and I'm going to wait until I see you're not writing anymore. Don't let me get ahead of you. Just slow me down anytime you need to.
So this, I'm sorry, the equilibrium price was 708, and what did you call that one?
The equilibrium price was 103,
Yes.
and the equilibrium quantity was about 706. Between 705 and 708, somewhere in there. Okay? Now, how do we change this sometimes? Look at this. We say, look, we did the research on some of these buyers, and we found out for the average buyer, this is his demand equation for one buyer. But in fact, your market has 6,000 potential customers. So if this is the individual demand for one customer, what is the market demand for all of them together, the whole market?
Just those same numbers times 6,000.
6,000 of these guys. Just multiply it by 6,000. And you'd say the market demand is 6,000 times the individual demand.
Can you take like the original price and just multiply that by 6,000?
No, it won't work. Trust me. Ask me how I know. I tried it many times. Okay? And suppose we are also told that besides yourself, there are 7 other sellers or competitors. So 7 others plus you means if this is their average individual supply function, then the market supply is 8 times that. 8 times negative 16 plus 17. Bingo. That's pretty high math, or at least long numbers. And so how would you find the market equilibrium? The market equilibrium price and the market equilibrium quantity.
Just multiply it.
Multiply these out and expand them and set them equal to each other. Solve for price and then substitute back in for quantity. Okay? Let me get a little philosophical for a minute. Are you going to do this as a manager? Almost certainly not. Is the concept important? Yeah, because when you get more competition and you multiply this by 22 instead of 8, it's going to bring that price down. So if you start getting more competitors coming into your business field, there's going to be a lot of competition driving the price down. But much more important than just the concept, my personal view on management. I am very heavily engaged in the other BAS degree that we just started this past fall, in supervision and organizational management. I've been teaching with the HSA program since it started. I think training managers is really important because there's not enough good ones out there today. And one of the things a manager has got to be able to do and not be afraid of it is to enmesh themselves in a lot of calculations and a lot of quantitative work to get to an answer. And so the degree to which you can immerse yourself in this stuff, work through all these arduous calculations and get to an answer and then explain it, that to me is indicative of you've got the mindset and the discipline and the talent to pursue management, to pursue the responsibility for organizations and for other people's lives, because that's what it is. If I did meet a student one time, and I think it was either this class or the finance class, and she was having difficulty, and she came to me and she said, I don't care if I learn this or not, I'm going to hire somebody to do this stuff for me. And I told her, you really should not go into the field of management. If you can't handle this level, this is not difficult, if you can't handle this level of stuff, and therefore you're going to rely on somebody else to do it for you, you don't know if they're lying or cheating or incompetent. And you never will until it's too late. And yet you're going to be responsible for decisions that rely on this information. And in your responsibilities, you're going to be responsible for the lives of other people. Your ignorance can cost people their career. And you're going to tell me you don't need to know this? I strongly recommended she quit the program and go into some other career where somebody would tell her what to do for the rest of her life. She didn't. I don't know where she is today, but she is a liability. If you can't sink yourself down into some calculations, work through them and make sense of them, management, not for you. People's lives depend on you being able to do your job. So we're going to do a lot of calculations. Next calculation. Overview, very quickly. Construct a demand curve from two data points. For example, we found that when the price of a product was $16, the sales of that product were 4,000 units per week. If we look back at our historical sales data, we can find that kind of stuff out. We kept looking and we found another point. We said, well, there were periods of time when the price was $20, and over those periods of time, the average quantity sold per week was 3,600. Good. There's 2 points. Construct a linear demand curve. Conceptually, what we're doing is this. We're saying at $20, sales were 3,600. Better move that back in a little closer. I'm going to draw this out of scale. And at $16, sales were 4,000. I've got 2 points on a demand curve. And so now I want to mathematically construct the equation for that demand curve, assuming that it's linear, that it's a straight line. That's a big deal exercise. That's something you're going to have to be able to do on the midterm and on the final. There are examples. There is a linear demand estimation handout with a sample problem that you need to kind of dive into. Maybe even before you start the problem sets, more on those in a minute. And I'm only going to start this for you for right now, just to illustrate what's going on. What we need to know is the slope of this demand curve and one of these points where it intersects. Either that point or that point. So the first thing we have to calculate is the slope. Now, if you took algebra but never did mathematical economics, they taught you wrong. They taught you the mathematical way, not the economics way. In math, or algebra, they taught you the slope was rise over run, right? Does that sound right? Rise over run? Well, now it's run over rise. The slope is the change in quantity divided by the change in price. That's because in economics we put the independent variable on the vertical axis and the dependent variable on the horizontal axis. And in algebra they do that the opposite. So don't be thinking rise over run. You will have it exactly wrong. So how do you do this? What's the change in quantity over the change in price? From one point to the other. The quantity goes from 3,600 to 4,000. At the time, the price goes from 16 to 20. Now, when the price went up, the quantity went down. So your slope is negative 100. The slope is always negative. It's a straight line going down. You see how we got the slope from 2 data points? Not really scientific, challenging type math. The next thing we really would like to calculate is this point here. I'll call it point A. How could we do that?
Just 100. It'd be 100 times 16, and then you just add that to 4,000 because the quantity drops with 100 each time it rises by $1. So
Okay. Conceptually, you're right on track. If the numbers weren't well rounded off nice and smooth, there's still a way to do it that's always right. What we're doing is we're going to go from point Z to point A, right? What's going to happen to the price there? How much is it going to go down? By 16, right?
Oh,
We're going to go from this to this. Price is 0. So what we know is delta P is negative 16. We know the slope is negative 100. Let's plug all that into the equation. Slope equals delta Q over delta P. So minus 100 equals delta Q over minus 16.
5,600.
Yeah, well, solving for delta Q. Delta Q will equal a positive 1,600.
And you just add that to 4,000.
And that is the distance right here. That's delta Q. That's $1,600 units. So you're going to go from 4,000 to an intercept of 5,600. This is the Q intercept. Q-I-N-T, the Q intercept. Gotta be fast. Delta Q over delta P equals slope. We know the slope's 100. We know that delta P was negative 16, so we solve for delta Q. Delta Q equals positive 1600. That's this distance right here. All right? Now, the general format for the demand equation, the way we usually express it, we say QD equals the Q-intercept minus the slope times P. So how would you write that? QD equals the intercept 5600 minus the slope times the price. I guess we did it all after all. Sir?
Q-intercept is the point, is point A, or is it the distance between 4,000?
Yeah.
No, it is the intercept where it intercepts this line. This is A is the Q-intercept. Good. Good for clarification.
And the distance between is just change of Q.
It's just delta Q. Yeah. So, if you do this 4 or 5 times conscientiously, it's real repetitious, redundant. So that should be, on an exam, a gift. Simple to do, same routine. You've got a couple of exercises where you're doing it in the problem sets. We'll make up another one every once in a while. We doing okay so far? Can I erase the board yet? I'm going to draw that demand curve again. I'm going to pick one of the prices when the price was $20. The quantity was 3,600. I'm just restating what we had. We know the equation for demand.
So are all the demand curves going to actually touch each?
We're going to extrapolate them to touch because we want to know what that value is. And all of them are going to be straight lines just because it's easier to do the math. Do you remember a term from microeconomics called consumer's surplus? Remember what it meant?
No.
Heard the word. Anybody else remember what consumer surplus meant? What?
What you get to take on, I mean, like, you were willing to pay $20. I mean, you were willing to pay like a higher price, but it's like on sale, so you have like
Perfect.
left over.
You were willing to pay a higher price, you went into the store and you found it at a lower price. You were willing to pay $50 and you were able to buy it at $40. It was worth $50 to you. It only cost you $40, you got a $10 consumer surplus. Now, if you were a business, wouldn't you like to have gotten at least some of that $10 from that customer? I hope, right? Well, graphically, when you say the price is at some level, and you can read out to the demand curve and see how many you sell, and you know that demand curve is there. The consumer surplus, when you sell these 3,600 units at $20 a piece, the consumer surplus is the area of this triangle. CS, consumer surplus. What we'd like to do is first understand the concept. But then second, understand how do we get some of that money back? So remember, if this was 3,600 customers and each one bought one, for example, there was one customer over here who was willing to pay a hell of a lot higher price. And then there was another customer here who was also willing to pay almost that higher price. And on, all the way down this line. So some of your customers are willing to pay a lot more than $20, but they're walking out the door with a big smile on their face because they didn't have to. How much money is walking out the door that your people, your customers would have paid you that you didn't figure out how to get it from them? That's the size of the consumer surplus. Now how are we going to calculate that area of that triangle?
Half base times.
1/2 the base times the height, right? Well, we know the base, right? The base is this distance here, 3,600. And we know what 1/2 is. How do we calculate the height of that triangle?
Find out.
We have to figure out what the price intercept is. How are we going to do that?
Since you know the slope is negative 100.
You know that slope equals delta Q delta P. We know that negative 100 equals, do you know delta Q or delta P?
You know delta Q is.
You know delta Q because Q's got to go from 3,600 to 0. So delta Q is negative 3,600. Solve for delta P.
Why is it negative when it's going
It's going from here to 0.
backwards?
Good,
Okay.
good question. If we do this, we wind up with delta P equals minus 3,600 over a negative 100, or 36, positive. So if you go from 20 and the price goes up 36, you know the intercept is at $56, and you know the height of the triangle is that $36. We doing okay? Everybody tracking with me? So how big is the consumer surplus? Let's go take a calculator. Anybody?
64,800.
$64,800. Questions on the 64,800? Anybody?
So, the 64,800 is the consumer surplus, which is basically the amount you lost.
It's the amount your customers would have paid you
Right.
if you knew how to get it from them.
So if I knew how to get it, I could have had.
You could have gotten at least some of it, right? Now, how much did your customers actually pay you? How much revenue did you receive when you sold this many units?
20 times 36.
$20 a piece times 3,600. So, total revenue equals price times quantity, which is 20 bucks a piece for 3,600 units. Is that right?
72,000.
72,000? So your total revenue is really this rectangle here. We doing okay with each other here so far? Anytime y'all need me to move to one side, just wave your hand. Now think about this. People came into your store willing to spend how much money?
56.
Total.
$56.
They came in willing to spend $72,000, which they did, and they were willing to spend another $64,800, which they didn't. So they came in willing to spend $136,800, and you didn't get but $72,000. How do you judge your efforts?
And they very well.
Boy, if you were working for me, we'd have a discussion. And if this was your company, how would you feel? I'm not making but about half of what I could. You see that? That's a hell of a lot of money to go walking out the door. If you add the consumer surplus plus the total revenue, you get what I call the total value received by the customers. That's the total amount they were willing to pay. That's their total value they received. And they didn't have to pay for it. Now, from a management standpoint, somebody needs to do something about that. And that's what this course is about. How do we go about getting some of that money? We may not get it all, but hell, what if I gave you 50 cents on every dollar extra we got? That'd be a nice bonus, wouldn't it? So our discussion will become, do all these calculations, tell me why this is a good or bad analysis, and then tell me, based on this, what can we do as a business to get some of that consumer surplus? Now, a quick illustration. Anybody here a car salesman? Everybody here bought a car? What happens when you go in the car lot to look at a car or buy it? I'm the salesman.
You annoy me.
I'm what?
You annoy me.
I annoy you. Why do I annoy you? Because I'm pushy. Perfect word. Exactly right. I'm going to come out, I'm going to nice smile, introduce myself, shake your hand, get to know you, and I'll start asking you a couple of questions. Like, are you from around here? Yeah. Are you trading in a car? Is that it? Okay. And then I'm going to ask you that little loaded question, right? How much are you looking to spend? And what are you going to tell me? Are you going to tell me the truth?
No.
Hell no. The fact is, you could probably come up with 15 or 20 grand. And you're going to look me straight in the eye and say, well, I'd like to get in for not more than about 12, 12 and a half. I know you're lying. You know you're lying. What car am I going to show you?
One that's 18.
18 is a good number. I'm going to take you over to that $18,000 car. And when the price tag says $18,000 and you look at it and you stop and you say, that's more than I wanted to spend, what am I going to tell you?
Well, we can work something out.
We can work on that, okay? You just tell me if this is about the kind of car you're looking for. If this is something you do between your trade-in and, I'll go in and talk with the boss, tell him about what's going on. I know we can bring this number down, okay? Why don't you just get in and see how it feels? What happens when you get in the car?
You want it.
You want it bad, right? And we keep going back and forth, and I go into that and I say, okay, look, it looks like this is the kind of car you could use. Let me go to the boss and see what we can do. And I go into the boss, and what do I say to the boss?
They want the car.
I got a live one out there.
Yeah.
What do you think we can do on that 18, Well, I'll see if they'll go for 16.8. And I come out to you and say 16.8, and you say, too much. I said 12, 12.5. I might go 13, 13 and a half, but I can't do 16.8. Well, let me go talk to the boss again, right? You ever been through that routine, right? And if we're not quite in agreement, what's the kiss of death?
I'm walking out.
You've been sitting in that car, running it, listening to the stereo system, you're falling more and more in love with it. I come out to you and I say, well, let me see where they are here.
What you take home from that?
Why don't you just take it home? Bring it back tomorrow morning, okay? And what happens if you take those keys?
You're stuck.
I own you. You work for me now. You will do everything you can to buy that car, because why? I have busted my butt trying to get you the best price I can for this car. I'm your buddy, I'm your friend, I'm trying to help you, and now you owe me. And there's that little moral obligation. And not everybody's that way, and everybody will say, not me. Well, most of you are damn liars. Because a lot of people will find a way to come up with that extra cash. What is that salesperson doing in terms of what we've talked about tonight?
They're increasing that.
Not just increase demand.
Trying to squeeze out all the consumer surplus.
Right. I'm trying to get every bit of consumer surplus out of you that I possibly can. So one of the ways we can capture consumer surplus is by having a sales force that works with every customer one-on-one, trying to get them to their maximum price. That's expensive if you have a lot of customers. When you have a lot of customers, the easiest way is to just set the same price for everybody, no negotiations. But between those two extremes, getting the maximum amount from every customer versus everybody just pays the same price, there are some other things we can do to capture some of that surplus. And if you as a manager can envision this and then come up with some ideas, I think you become more valuable. Okay? There's where we're going. There are 5 problem sets to use to work on for the midterm. When we meet again in 2 weeks, you should have completed the first 2. Some of it we've covered tonight, some of it is explained in some videos that are referenced on the Canvas website. If you have any questions as you're working through that, post them to the discussion forum so that I can answer them and everybody can see what we're talking about, how to solve a problem. If you have other issues of a more personal nature, email me on the Canvas system and we'll resolve those difficulties. That's the nature of this course. When you look at the syllabus and all that, the big thing first probably is the course schedule. It shows you the topics week by week and the videos to watch and work to do.
I have a question.
Yes, ma'am.
Sorry, how do I find that? I'm trying to get used to the Canvas, but
I've got courses set up a couple of different ways. It's either in a module called Administrative Documents, and it's almost surely there. And it may be on a page called a Course Schedule page.
Our class is a course schedule.
It isn't
Yeah.
in the Course Schedule page or in the module?
Page.
Okay, yeah, that's what I'm thinking. I set it up on the page. When you go to the page, you can just click on a video and it starts playing. So either one of those. This is not complete. The second half of the course, I have some more materials I'm getting together, some videos for you to watch, some articles for you to read. So I will put on the announcements when I update this with new material. But as far as getting ready for the midterm, those 5 problem sets are really where you want to be. Yes, ma'am.
I was looking at the date for the midterm, and it shows like the day of the week and then the date, but the date and the day of the week don't match up. So I was wondering if it was, the date was correct or the day of the week was correct.
The highest probability is that I screwed it up. The second probability is the course schedule down the column here says for the week of, and so that's always the Monday date. And then when you get over here, it has the correct date. And if they're mismatched, that was for the midterm?
For the midterm, it says like Tuesday, and then it gives the date, but the date matches with the Wednesday. So it just wasn't sure.
Yeah,
Let me see if I can find it.
it's July 1st week.
Yes, it should say midterm exam Tuesday, July 2nd.
July 2nd.
Yes, I will correct that, thank you. When you find other errors like that, please email me, let me know. I need all the help I can get. Anything else? No?
so we need to do between now until
In 2 weeks, when I meet you here again, problem set 1 and 2.
1 and
Is there anywhere where the answers are posted so that we can check our work?
Yes, the answers for the problem sets are on Angel. They're handwritten by me and scanned, so you gotta read them careful, but I tried to be neat. Okay? Anything else? And last morning, the Alachua County Sheriff's Office patrols 39th and 23rd Avenue regularly out here. Be careful driving home. Okay? Bye.